Hi, and welcome to your first flipped classroom and video lesson. Most of these will be me recording the audio, and so it will seem familiar and probably in a familiar pace and style that you're used to. So we're going to start with, we're starting a unit on quadratic functions, which you spend a lot of time on in Algebra 1 and in Algebra 2. So we're starting with some review, and this unit itself will be fairly short. We're starting with just skills review, and then we'll move into graphing quadratic functions and applications of quadratic functions. So here we go with our review. Looking at creating quadratic functions, we can create quadratic functions by multiplying polynomials or binomials. This is just a little review, so I'm going to work through the examples and talk as I work. And then in class tomorrow, on Monday, we'll be working through some of these on our own. So if we want to expand and simplify the expression, the first one, we're going to distribute 3x. That means we're going to do 3x times x minus 4, and we're going to do 2 times x plus 1. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. Then remember here, when I start to distribute the 2, it's actually a negative 2 right there that I'm distributing. So I'm going to pay attention to that negative. Negative 2 times x is negative 2x. And negative 2 times 1 is negative 2. Then I'm going to simplify, because those are the directions to expand and simplify, by combining like terms here. So 3x squared minus 14x minus 2 is my final answer. I'm going to not do anything more than that. I'm not going to try to factor that or solve, because it's the directions say expand and simplify, and I have no equation to start with. I just have an expression there. So I've just changed the way that expression looks. The same thing with number 2. Here I'm going to distribute the x times the x and the 5, and then the negative 3 times the x and the 5. This, sometimes you learn this in Algebra 1 or 2 by a mnemonic called FOIL, first, outer, inner, last. So I'm actually just distributing the x times x with x squared, or if you like FOIL, that's the first times the first. Then the outer, or x times 5x, is 5x. So just continuing to distribute the x. Then I'm going to come back and pick up the 3, and again I'm going to see that as negative 3 right there. See the negative that I'm distributing? Negative 3 times x is negative 3x, and negative 3 times positive 5 is negative 15. Again, x squared, I'm combining like terms here in the middle. Positive 5x and negative 3x leaves me with positive 2x, and subtract 15. So just a reminder that exponents increase when I'm multiplying, so x times x gives me that exponent of x squared. If I'm adding or subtracting, like 5x and negative 3x, then I'm only dealing with the coefficients. So I'm dealing with positive 5 and negative 3 gives me positive 2, and the power on x does not change. A change in power requires multiplication. The last one, remember this is a binomial because there are 2 parts to it, the 2x and the 3. Anytime I'm squaring a binomial or a trinomial, something with multiple terms separated by addition subtraction signs, I have to write it out. I can't just square the first and the last terms. So 2x plus 3 squared means 2x plus 3 times 2x plus 3. And now I'm back to doing exactly what I did in number 2. I'm going to distribute the 2x by the 2 times the 2x and the 3, and then the 3 times the 2x and the 3. There are no negatives in this one to be concerned about, so I don't have to pay special attention to the negatives. So I'm doing 2x times 2x, that makes 4, and then I'm doing x times x, and remember that's what gives me the power of square on the x. 2x times 3, I just multiply the 2 times the 3, that gives me 6x. No new power on x because I didn't multiply an x times an x. 3 times 2x gives me another 6x, and then 3 times 3 makes 9. Again, combining those two middle terms because they're like terms, 4x squared plus 6x makes plus 12x plus 9. I'm going to box in the answers to give you a minute to think if you're following along. So that's a review, and then just some things to pay attention to overall. Notice that I did not solve anything at all here. There were no equations to start with. So when I started, I only had 3 expressions, no equals to something. So I can't solve for x. I can only write new expressions. Now we're switching gears and factoring, so we're going the opposite way. These expressions are already expanded with like terms combined, and we're being asked to go back and factor. Again, notice that we have a list here of 6 expressions and the directions say factor. There's nothing to solve, there's no equation, so we're not binding x. We're just factoring. So just I'm going to remind you of different factoring patterns. I have an example of each type here. In addition, then we'll look at some solving quadratic equations by factoring. So we're just starting here with factoring. The first type of factoring that I always look for first is a greatest common factor. This first expression has a greatest common factor, and in fact, multiple greatest common factors. So the first thing I check if I'm looking for a greatest common factor is there a numerical value that will divide into the coefficients of both 5x cubed and 15x squared? And there is. 5 will divide into both of those. Then I check variables, x cubed and x squared. There is x appears in both, and in fact x squared will divide into both of those terms. And so I can factor out 5x squared, and let's look at what I have left. So if I take -5 and divide it by 5, I have a negative left over, or -1. X cubed divided by x squared is x. Or another way to think about it is I'm trying to kind of break out 5x cubed. I have 5x squared of it outside. That leaves me a negative and an x on the inside. Plus, again, I have 5x squared on the outside. So it must have come from here was a 3, because 5x squared times that 3 would give me the 15x squared that was in the initial expression. I stop and check. I can't go any further. The term that's in parentheses doesn't have any powers on it, so I factored as far as I can. So I'm done. Okay, the next example, I notice that there are 3 terms, x squared, 5x, and 6. I notice the signs between them are all positive. I notice that I have no greatest common factor, because if I look, it has to divide into all 3. 1 is the only numerical value that would divide in all 3, and there isn't an x in all 3. There's only an x in 2 of the 3. And so there is no greatest common factor. Then I am reminded, this is called a trinomial. My rules for factoring a trinomial I have some sign rules. So I'm going to write a little and then I'll erase it before I start to factor. So I'm essentially looking for things that multiply to make the last term. And as long as I don't have a coefficient on x squared, I'm looking for things that add to make the middle term. So if my last term is positive, and I've multiplied to make it, that means the signs in my parentheses when I go to factor have to be the same. They either have to be both positive or both negative. I can look over one term, so this, because that's a positive 6 there on the end, the signs in parentheses either have to be both positive or both negative. Can look over one term to the positive 5 and think, oh, well, they must be both positive because I've added to make a positive number. So that helps me get started. So I'm going to erase that and then I'll actually do the factoring. So I'm going to start with my 2 sets of parentheses. I don't have anything common, so I know I'm doing the 2 parentheses. If I'm multiplying to make x squared, I know I had to have x and x. I have a positive 6 on the end. Signs in parentheses are the same. Positive 5 in the middle, both positive. I'm trying to multiply to make 6 and add to make 5. The factors of 6 that add to make 5 are 3 and 2. I could check. X times x is x squared, plus 2x plus 3x, just foiling back together. That would give me plus 5. 2 times 3 makes 6. Good. Okay. Do the next one. Again, no greatest common factor. This is almost the same as the one before it, so I know there's not going to be any greatest common factor. If I check my signs, the sign on 6 is positive, so the signs in parentheses are going to be the same. The sign before it is negative, so that says same, both negative. So x and x to get my x squared. Signs are both negative. If I'm multiplying to make positive 6 and adding to make negative 5, that's a negative 2 and a negative 3. Again, I could check back. X times x is x squared. Minus 3x minus 2x makes minus 5x. Negative 2 times negative 3 makes positive 6. All right, feeling good so far. If I look at the next one, it's almost the same. The only thing that's changed is that now my 6 is negative. If my last term, if the coefficient of the constant there is negative, that means the signs in parentheses are different because I multiplied to make a negative number, and the only way I can do that is with a positive times the negative. So x squared, again, I have to multiply to make x squared, so x. The signs in parentheses are different, a positive and a negative. I have to multiply to make negative 6 and add to make positive 5. 2 and 3 won't work anymore. They multiply to make 6, but there's no way if one of them, if a 2 and 3, if one's positive and one's negative, the difference between those two numbers is 1. So there's no way I'm going to get 5. So I have to think more about factors of 6. My other possibilities for factors of 6 are 1 and 6. Okay, so 1 and 6, if I had a positive 6 and a negative 1, then positive 6 times negative 1 makes negative 6, and positive 6 minus 1 makes 5. So I found it. I could multiply back again to check. X times x is x squared. So far, so good. X times negative 1 is negative 1x. 6 times x is plus 6x, so that makes plus 5 in the middle. Positive 6 times negative 1 makes negative 6. So that's good. I've got it. Last one. Almost the same, except now both the 6 and the 5 are negative. That negative on the 6 tells me that the signs in parentheses are different. One positive, one negative. And then I think of factors of negative 6 that would add to make negative 5. That means I need, from the one above, I now need my 6 to be negative and my 1 to be positive. Then I can check 1 times negative 6 is negative 6. 1 plus negative 6 is negative 5. And so I've factored that correctly. So again, if I just skim down through 2, 3, 4, 5, in 2, positive 6 means signs are the same. Positive 5 means both positive. 3, positive 6 means signs are the same. Negative 5 means both negative. In number 4, negative 6 means signs are different. The positive, I don't know, I'm going to have to check it out. And in number 5, the negative 6 means the signs are different. And then I just have to think about which one do I need to be negative in order to get negative 5, positive 5. Now, if I look at number 6, things have gone differently. So I have to stop and look. And I notice that there's not a greatest common factor. This was not the same as all the rest, so I have to go back and check for my greatest common factor. 2 would divide the first term and the last term, but not that 5 in the middle. And there's not an x that's common, so I have no greatest common factor. So I'm going to move on. Then I notice, I have this 2 on this x squared. And that means that my little convenient pattern of multiplies to make the last term and adds to make the middle term doesn't work anymore. And so I have to try something else. So I am just going to use old trial and error. So I know that the first terms in the parentheses, the first times the first, has to multiply to make 2x squared. And I have no choice about that. The only thing that could possibly multiply to make 2x squared is 2x times an x. My sign rules still work. So I see that my last sign is positive. That means the signs in parentheses are the same. And my middle sign is negative. That means I have both negatives. Then I just think of factors of 2. Well, the factors of 2 are 2 and 1. And I don't know this time what order they go in the parentheses, so I'm just going to stick them in there, 2 and 1. And then I'm going to check. So here I am checking. I'm going to put a little check mark beside there. And I'm going to put a question mark out here because I'm not sure I've found the right answer yet. I have to check to see if I have a coefficient on that x squared. So 2x times x makes 2x squared. It's looking good so far. 2x times negative 1 makes negative 2x. Negative 2 times negative, that makes negative 2x. And negative 2 times negative 1 makes positive 2. Well, that does not work because 2x squared checks, but then negative 2x and negative 2x does not make negative 5 in the middle. So this is wrong. Wrong. So I'm going to erase it. Maybe. Yep, there it goes. Erase, erase, erase. Wrong, wrong, wrong. And the first thing I'm going to try is reversing where I had the 2 and 1. So I'm going to put a 1 here and a 2 here. Now I'm going to check again. I'm going to put a question mark out here because I'm still not sure. So I'm going to check again. 2x times x is 2x squared. 2x times negative 2 is negative 2x. Negative 1 times x is negative 1x. Negative 1 times negative 2 is positive 2. 2x squared checks. Negative, oops, 2x is 4x. Negative 4x and negative 1x makes negative 5x. And positive 2, it works. And so I have it. So I can erase my question mark. And I can leave my check or erase it. You can do your check mentally. You don't have to write it, but you do have to check if you have a coefficient on x squared, because you're just trying things until you find something that works. All right, so that works. So I found it, and I don't have to check anymore. So strategies for the ones with there's coefficient on a 2x squared. So if I have the wrong number, the first thing I do is change order of the last two factors. If that doesn't work, I may have to go back and think of other things that would multiply to make 2, other factors. In this case, I didn't have any choice because I had a 2 at the beginning and a 2 at the end, so my only choices were 2 and 1. But if I'd had, say, a 6, I might have tried 2 and 3 first, and then if that failed in both orders, I would have tried 6 and 1. So I'm just trying things until I find the thing that works. Okay. Oh, now this is different. The instructions say solve, and I have an equal sign here. So this is a little bit of review of using factoring to solve quadratic equations. We'll review some other ways to solve quadratic equations in this unit, but since we're reviewing factoring, we'll go ahead and review factoring as a way to solve an equation also. So I'm going to use factoring here to solve this quadratic equation. And so it's helpful to me that my idea here is that right now I have a whole bunch of things added or subtracted to make 0. That's what this equation is telling me. 2x squared minus 3x minus 5. So 2 times something squared minus 3 times something minus 5 makes 0. So adding and subtracting. And I could spend all day thinking of things that add and subtract to make 0. There's a lot of things that add and subtract to make 0. So that's not really helpful. But if I had two things multiplied to make 0, then I know that one of those two things has to be 0. So one of these, 1 must be 0. That's called the zero product property. Product meaning multiplication. And what that means is that if I've multiplied and the answer is 0, then one of the two pieces of the product have to be 0. So there are two things that are special about that. One of them is that on this side, I have to have 0 because it's the zero product property. The other thing is that I have to have multiplication between the two things on the other side because it's the zero product property, not the zero sum property or something else. And that's because multiplication equal to 0 in particular is very, very special. So if I had two things multiplied to make 4, I can think of a whole bunch of things. 2 times 2, 4 times 1, 1/2 times 8. There are lots of things. That's why there's not a 4 product property. It's a 0 product property. So in order for factoring to help me solve a quadratic equation, two things have to be true. One, it has to be equal to 0. And two, I have to create a product from this addition subtraction. So that's why factoring helps, because I have my equation equal to 0. And if I have a quadratic expression we just saw, a lot of times I can factor that and I can change it from a sum or difference into things that are multiplied. So that's what I'm going to do first. I'm going to factor, it's already equal to 0. So the 0 part of the product property is satisfied. Now I have to create a product. So I need to factor this left side. This is one of the hard kinds of factor because I have this coefficient out here on that x squared. All right, so here I go. I'm going to start there isn't a greatest common factor. There's nothing that divides 2, 3, and 5, and there's no common variable. So I'm stuck with the hard way. So 2x squared, 2x times x is the only possibility. My last sign is negative. That means the signs in parentheses are different, so 1 plus, 1 minus. And then I look for things that multiply to make 5, and the only thing I know that multiplies to make 5 are 5 and 1. So I'm just going to stick it in, 5 and 1. And then remember I have to check, so I'm going to come over here and check. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 5 times x is plus 5x. 5 times negative 1 is minus 5. Checking these middle two. Negative 2x, positive 5x, that makes positive 3, not negative 3. If I have the right number and the only thing that's wrong is the sign, I just need to switch the order of these signs. So I can leave the numbers sitting right where they are, make this one positive, and make that one negative and this one positive. That one negative, come back negative sign. Okay, I'm going to erase my checking. And check again, check, check. 2x times x is 2x squared, good so far, plus 2x minus 5x minus 5. The plus 2x minus 5x makes minus 3x in the middle, and I found it. So I'm going to erase my check. You don't have to erase your checks. I just don't have a lot of space on the screen, so I'm going to erase mine. So now I am in great shape to use the 0 equal to 0 product multiplied property, which says that if I have two things multiplied to make 0, one of them, either 2x minus 5 was 0, or the other one of them must have been 0. There's the product, and if I have two things multiplied to make 0, one of those two things has to be 0. So I can just set each factor to 0. And then solve pretty simple little linear equations. I can add 5 here and divide by 2. So x is 5 halves. Subtract 1 there, x is negative 1. And I have my two solutions. Okay, the next one, already equal to 0. My only job is to make a product. And so I'm going to squish in here because that one took a lot of space. So here I go with my factoring. 2x and x to get 2x squared. My last term is negative, so 1 positive, 1 negative. I've multiplied to make 5 again. This one's not going to factor. I've multiplied to make 5 again, so my only choices are 5 and 1. And you just heard me say this one's not going to factor. Well, let me show you why. So if I have it in this order, 2x times x is 2x squared. And then 2 times negative 1 is negative 2x, 2x squared, negative 2x plus 5x minus 5. Well, I get 3 in the middle. Switching the signs won't help. That'll only give me a negative 3. And I can't switch. I can switch places with 5 and 1, but if I do that, things actually get worse. It's not erasing. I'll try to exchange and put the 1 here, no, the 5 here, and the 1 there. Well, that, if I check my outers and my inners, that gives me negative 10x and positive 1x. That's not positive 1. So this one doesn't factor. Uh-oh. So now what do I have to do if it doesn't factor? Well, I have to use my old friend quadratic formula. I'm going to write a note here. Quadratic formula. And the quadratic formula looks like this. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to erase the word quadratic formula. I'm going to label my parts. Okay, you say. So that's a way to get me what x is equal to. But what are this a, b, and c business? Well, a, b, and c are just the coefficients of this quadratic, labeled in order. So the coefficient of x squared is a, the coefficient of x is b, and the constant is c. So if they're in some funky order, you have to put them in order before you identify your a, b, and c. So I'm going to use quadratic formula now. X equals the opposite of the coefficient of x, so negative 1 plus or minus the square root of 1 squared minus 4 times a is 2, the coefficient on x squared, c is negative 5, about to run out of space there, all over 2 times 2. All right, I'm going to erase the formula so that I have a little more space here to get the final answer. And simplify a little bit. X equals negative 1 plus or minus the square root of 1. And then I'm going to think of this as negative 4. So negative 4 times 2 times negative 5 is positive 40 all over 4. Negative 1 plus or minus the square root of 41 over 4. And you may leave it in that form. You don't have to do any simplifying. But you're like, well, wait a minute. I thought there should be 2 answers. When we factored, we got 2 answers. There are 2 answers here. There's negative 1 plus the square root of 41, all divided by 4. Or there's negative 1 subtract the square root of 41 divided by 4. If you want decimal answers for these, make sure that you put the numerator in parentheses before you divide by your 4. It's fine to leave it in the radical form, though. You don't have to find the decimal approximation. So, oh yeah, good old quadratic formula. All right, let's look at our last example here, and we'll see if it factors or if we need to use quadratic formula. Just as a side note, you may always use quadratic formula, but it takes longer if something factors. And so I will not, at this point, require you to factor to solve, but I will warn you that sometimes factoring is easier and faster than quadratic formula. All right, so let's see if this one will factor. I've got 0. So I can use the 0 product property here. 3x times x makes 3x squared. I need it equal to 0 on that side. 6 is 2 and 3, or 6 and 1. So let's check 2 and 3. I've got a negative there, so I've got a sign of each type, one positive and one negative. And instead of checking the whole thing, because I'm trying to factor quickly, I'm just going to check the outers and the inners from FOIL, because the negative 2 is what's a mystery. So let's see, if I check my outers, I get positive 6x, my inners negative 3x. That doesn't make 2. So let's erase that. That doesn't work. Let's try flipping the 3 and the 2. That makes 9x minus 2x. That does not make minus 2. Nope. So then my other option is to try another factor of 6. So let's try 6 and 1. 6, 1. plus 18 minus 1, that does not make negative 2. So checking my outers and my inners, nope, not negative 2. Just erase that. Let's try flipping places with 6 and 1. Positive 3x minus 6x. Oh, that does not make it negative 2. So this one also won't factor. So I'm going to have to use quadratic formula here also. This one is also in a nice order, A, B, C. So here we go. X equals the opposite of B, 2, plus or minus the square root of B squared. Negative 2 squared is 4, minus 4 times A times C, all over 2 times A. And that gives me, I'm running out of space, so I'm going to come down here at the bottom, 2 plus or minus the square root of 4. And then negative 4 times 3 times negative 6 is negative 12 times 6 is negative 72. So a positive 72 because I've got negative 4 times negative 6. So 76 all divided by 2 times 3 is 6. And I can leave it that way. Don't have to simplify. I can just leave it that way. X equals. Okay. All right, I'm going to erase some of this work. So take just a second if you're taking notes. Go back in the video or pause it so you can finish those problems. And I'm going to write the quadratic formula because I erased it up here so that you'll have it in your notes. All right, so I'm going to erase the work for this last problem and write the quadratic formula in case you didn't get it the first time. Okay, here it is. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, that's it. Thank you.